Okay, good evening, everyone. Welcome to join with us for this technical webinar for our elevator control system. Now we are in our live room at the Innovance factory. So maybe you already heard of our Nice series products, which is very famous for the name Nice 3000 or Nice 1000. And today our technical expert, Mr. Ian, will give you a more detailed introduction about it. And some of you may already be familiar with that. So we are also hope that you can give us some positive feedbacks about your experience of application. So today let's just start. The first part will be the introduction of our products. So I will hand over to Mr. Ian, please.
Okay, thank you, Ray. So good evening. Maybe good morning at the South America. So this is Ian speaking from Suzhou Innovance, Suzhou Monarch factory. So I'm very it's my great pleasure to be here today to share the Nice series product, the main features, main benefits, and also the same side experience. So now we just start. So here is a brief explanation of Monarch main product from the encoder, sensor, and lift inverter integrated controller, and also control panel and the package solution. Today we are focusing on the integrated controller, the Nice series integrated controller. For our Nice series integrated controller, we have three main products. That is Nice 3000 Plus, Nice 1000, and Nice 100 Plus. Their main difference is basically they are all integrated solution, integrated product. That means the motherboard and inverter integrated. But their main difference is for Nice 3000 Plus, it is for serial communication. Nice 1000, it is for the parallel communication. And they are both for the closed loop. That means we need install encoder, whatever is the induction motor or the PM. But for Nice 100, it is for open loop. Open loop means we don't have to install the encoder. For Nice 3000, it can for standard solution it can support maximum 40 floors. For Nice 1000, for the standard product it support maximum 8 floors. The open loop solution it support only 6 floors. And the difference for the HOP and cutoff, the difference is serial communication and parallel, and also for the enclosed loop, it support both induction motor and permanent motor. And for the open loop, it only support induction motor, gear motor. The maximum speed, Nice 3000 Plus 4 meters per second. Nice 1000 Plus 1.75 meter per second. For the open loop, Nice 100 Plus 1 meter per second only. So for today's discussion, we will spend most of our time, most of the section we will discuss the Nice 3000 Plus. Because generally we share the basic idea, and also our main product and most of our selling is actually a Nice 3000 Plus. So for Nice 3000 Plus, it is stable and quality. So since the Monarch Foundation, the year of 2004, over 3 million units has already provided. So now over 3 million units in operation worldwide. So that is to say, the Monarch product is stable, quality, and verified. So we are 100%, we are absolutely confident of that. And and it's user friendly. It is not just the user friendly is not just because the motherboard and the inverter integrated. It is about our design and the design logic. It is less parameter adjustment and easy wiring installation, and also high performance. Our product has been used for various different brand models, so it can intelligent. Also over 18 years experience in the lift control field. So it is 18. Just hold a second. Okay, we start again. So just continue previously explanation. So 18 years experience in lift control field. So it is a accumulation of the experience and technology and features and platform. Yeah, Monarch is a subsidiary of Innovance. Innovance is the industry field of control drive. So we just stand. Monarch is standing on the shoulder of the Innovance. So we share the same. We share the basic technology and platform, and also keeping innovation. Monarch is a pioneer in the lift control technology field. And talking about the 93,000 plus, a minimum arrangement is a drive. For example, the 11 kilowatt, a drive and a PG car, and also cut-off board and cut-off board, and plus the connection cable, and also the indicator for HOP, for COP, and the keypad. For the keypad, so later on we will share what we offer, because now we are releasing a new tool that is a Wi-Fi smartphone based app commissioning connection through a Wi-Fi module. So later on we will share about that. So about the model, just now, for example, the 11 kilowatt, 400 voltage. If it is 200 voltage, the model will be 220, and dash nice dash L dash C dash 4011. So the model will be different for the 400 and 200 voltage. And here is the two main hardware of the NICE 3000 plus. So the left one is we call the socket one. The difference is actually the motherboard. The left one is the socket with a 40-pin socket. We use this version for Monarch Mac control panel because it should work with Monarch Mac interface board, the module I/O field I/O board. And the right one is the traditional I/O version. We just the wiring connection to the motherboard directly, input and output. The difference in the model for the socket version is KZG. This is the two main version of the hardware. And here is the detailed explanation of the hardware. So this is a USB port. It is to connect the Wi-Fi module. So we can use smartphone to do the commissioning, to do the parameter checking, and also the parameter setting, upload, download. This is the battery, lead battery. The battery is not supplied to the motherboard. It's to the time chip. It's to the time management. So even the power is off, the time is still on. And here is the SPI communication. Is for the communication of the motherboard and the inverter. Is the RJ45. It is to the connect to the remote keypad. It is the traditional keypad. And here, this area is for the PG card installation. And CAN 2 is for the duplex connection. CAN 1 is for cut-off connection. And Modbus is for the HOB. And it's a three digits indicator to display the basic lift status. And also the 3 buttons. We call the mini keypad. It has easy access to the lift operation. In case in some side, my engineer may forgot to bring the keypad, so we can use that 3 buttons for a faster communication, for the faster commissioning. And also the LED is to indicate the communication, the serial communication, like CAN bus, Modbus. And is a LED indicates the input signal status. And here we have 24 digital inputs, and also analog. Also an analog. One analog input is to connect the overload sensor. So the motherboard analog input is actually used in the case the load cell is installed at the machine side at the rope terminal, directly attached to the rope terminals. And here is the high volts digital inputs to connect to the safety, to connect to the door lock safety. And a relay output to control the run contactor and brake contactor, kind of that. And the main circuits connect the incoming power and also to the motor, and the braking system also connect here. The dynamic braking resistor. So the next we are going to share the main features, and that is when we how we select suitable models, and how we manage to start. So first of all, nice 3000 plus one drive can support both the induction and PM motor, geared and gearless. Different is the PG card. We have A2 for the incremental encoder, also the DC12, and PTD is for the incremental encoder, the DC5, and also the signal is different like A plus, A minus, plus, B minus. So in some case for the PG, in some case in the PG, it's not about the motor. So K motor and gas motor, we both can use PGD. The difference is the encoder. If we use the PGD for a gearless motor, the system require ABZ signal, and this signal is connected to the U to the PG card U channel. And the next is the PGE. PGE is for the sine cosine encoder, and PGF1 is for the absolute encoder. The settings for different encoder is for F100. The 0 stands for sine cosine, 1 stands for UVW, 2 stands for AB incremental, and 3 stands for the data. And the 9000 plus we use the S curve. We call the S curve distance-based distance-based control. It is direct stop, so it can bring more efficient for the running, and automatic generation for the running curve. It can also bring extra benefit. That is, it can easily support. It can easily support the ultra short floor-to-floor distance. For example, for less than 500 mm, so it can easily support just to enable the one parameter B11 of F611. And for the duplex control, for two-leaf duplex control, just connect the CAN2 leaf A and leaf 2, the CAN2 plus and CAN2 minus directly connected. And here the cable we recommend using a 2-pair twisted shielded cable, and also the ground, both leaf the motherboard ground we recommend directly connected. It is recommended to connect the ground. I mean here the CAN2 ground common, more accurate. The setting is the common. The CAN2 common we recommend connect the common. If more than two leaf, we will use it will require to use an extra board. We call the grouping board for 3 leaf and more than 3 leaf. So maximum 8 leaf in the group control. And here's a different for the planning. Some of you may experience already experienced it. That is F642. We are already before setting is 0, but now function is to 1. So in case you have some connecting issue inside, to get that parameter should be changed to 0. F642. About the leveling sensor, the controller can support 1 sensor, 2 sensor, 3 sensor, or even also the 4 sensor. 4 sensor is required for UCM and also the advanced open door features. And suppose you did not use the Monarch sensor, and our input only support the PMP type sensor required. That means the high was effective for the digital input. And the leveling plan is recommended to be less 300 mm. That is the total height. The total height is suggested to be less 300. And in case you may have not aware of this, so in our new system, the latest version, the leveling sensor also support to transfer to the machine room by the CAN bus. Suppose we use 4 sensors. The upper and lower sensor, the signal can be transferred to the control panel by CAN bus. And if you use 2 sensors only, we can use the parameter to disable that application for the leveling. And another feature is leveling. So another features I should mention here is the leveling accuracy adjustment. So we can directly use parameter that is starting from FR00. Starting from FR00, we can directly input the leveling adjustment into the parameter. And so one parameter stands for 2 floors adjustment. So the benchmark is 30. So more than 30 is to adjust, the leveling is adjust to up. So less than 30 is adjust to down. So one parameter is for two floors. For example, if R01, the lower two digits is for floor 1, the upper two digits is for floor 2. And the next is UCM. We use extra board, extension board, like SCB A1 and SCB D for single door and dual door for the advanced open door or UCM. And also the braking force detection. These two features is all about Chinese new standard. It has become compulsory 5 years ago, but still our overseas friends maybe have not used it, because it's not just about the system. It's not about the control system. It's also about the machine, the brake. So it is a complete system. And besides the UCM and also the braking force detection, it has two ways for testing. One is a periodic testing. Every 24, that is every day, every 24 hours, it will perform the braking force detection automatically when leave in idle. And manual test is just we have talked. We have 3 buttons in the motherboard that we call the mini keypad. So we can use that mini keypad to change the parameter FA to A. It will start the testing. And the motherboard. So in general, still many friends sometimes just for me. So why my motherboard display the three A's? So is there something wrong? Is there something wrong with my motherboard? It is broken or it is faulty? So it is actually not, because it is doing the testing of the braking force detection. So at that time the motherboard will display AAA. So it is not about faulty. It is testing. So after the testing, the testing result will be restored to the parameter F709, F70. 1 means pass, 2 means failure. And in some case, because the testing is actually to test the brake. It's not to test the control system, not to test the controller. It is to test the braking force of the motor or road gripper. It is that testing. So the testing process. So we have parameter to keep the top. The logic here is if the brake should be applied and the control system output a torque and direct a torque to the motor, and there will be a movement. But even the brake is applied, and we detect the encoder pulse. If the encoder pulse has been larger than the threshold, then it means failure. And we can change the torque output time and also the maximum torque output for different brake. And the other one for the feature, it is to automatic recognition of the balance of the cabin and control the balancing coefficient. And we just make sure the lift capacity and the motor rated current is set correctly, and then we change to the parameter F324 or the mini keypad F8 to 11. It will start to detect the balance coefficient. So at this process, the HOP will display RI. So that after you keep that parameter, the leaf will automatically start to running up and running down. After the testing, it will save the learning result in the F713. So that parameter you can check the balance coefficient. So next I want to share you is the setting up by bits, because internal even we have installed 3 million units in the market, but internal still some friends are asking me how to set the bit, because it is so integrated. It is so many features in the controller. So we use so many parameters for different bits to enable and disable the different features. So here is I just take a short video here, so we can check. We can easily check here how to set the bit of the parameter. For example, we set F652. So first of all, the up button, the down button, we change to F652. Then at that moment you will see first of all it will see the data. It is in decimal. This value in decimal, not by bit. Then it will display by bit. This is the left 2 digits means a bit. Left 2 digits means a bit. The right 1 digit means the value. The value should be only 1 or 0. See, that if it is bit 6, then you use the down and up button to change the left 2 digits to 6, 06. See, then change the right digits to a 0. See, then the data will change. That's the simple logic. Then we're talking about safety. First of all, it is strictly compliant to Chinese lattice standard lattice regulation GB 758.1. It is just lattice released to the market. It has become it is not compulsory. It is a recommendation standard in China right now. And also the hardware and software redundancy design. It is one chip for the motherboard and one chip for the inverter, and also the door lock subject direct to inverter control from the X27. So that's why the door lock circuit we are suggested connecting to the X27, because this input is directly connected to the inverter. So in case there is a break of the subject or there is a break of the door lock subject, so the inverter and motherboard can immediately shut down the auto. That's why. And previously at the beginning, our old version, nice resulted. The safety input, the door lock safety input is actually connected to low voltage X4, X5, the digital input, the low voltage, but not the native version. For the nice 3000 plus, we are using the high voltage input, and using the high voltage input, then. And we suggest use the X27, because the X27 is directly connected to the inverter. That's why. So there is a slightly different here, and also wide range working temperature from -10 to 50, but more than 40, the model selection should be directed That means if the motor is like 7.5 kilowatt, the motor is 7.5 kilowatt, and the working temperature is like 47. So we suggest using 11 or 15 kilowatt of the controller. And talking about the keypad, our traditional one is just a simple keypad. That is 5 digits of 7 segment keypad. Now we are releasing the latest one, and also more smart one. That is we using the Wi-Fi connection. Use USB. It's not a USB speaker, just a USB port, but it is actually the Wi-Fi module. We use a smartphone. The smartphone should install Monarch app. Your smartphone first of all install Monarch the app, and then use the Wi-Fi module, connect to the motherboard. Then you connect by the Wi-Fi. Then you can check the parameter. You can do mostly to explain of you how the smartphone app work. First of all, start enable your hotspot, and then the default. If you get a new one, if you get a new Wi-Fi tool from an app, the default name and default parameter will be the name will be left. So here you change the Wi-Fi, the hotspot, the name to live, and the parameter to 1 to 8, 1 to 3, 4, 5, 6, 8, and then you will see the connection. You will see is there a device connect to your phone? There will be a notification. Here icon. It means has been connected. Then turn to the local debug. It is keeping connection with the controller. If you want change the parameter, then you just. And also here we can change the parameter by bit. So if change by the bit is more convenient than say by the compared to the keypad. I mean the 7 segment keypad. See if we change the for example here the F642. If we change the bit, it's quite easy. Just on off. You just press, so it will give you a feedback. Immediately give you a feedback. If you want to upload this parameter setting from this list, and in future you can make a recording, or in future you can download into other lists. So here we have a way to do that. First of all, the parameter import, but exporting means it is uploading the parameter setting from the controller to your phone. Set means you can make a name here for your either definition in future. Like we say office testing. Then here you can check just now. This is the parameter setting for this list. And after you upload to your phone, you can also share the parameter to someone else. For example, you have if the lift has a problem inside, you turn to someone help for the troubleshooting, so you can share the parameter to your friends or to our engineer. Then the engineer will receive your parameter setting, so it can help you to do the troubleshooting. Besides this, so by the smartphone with Wi-Fi connection, so it is possible to download to upgrade the firmware at the job site. Use some app. First of all, you import the firmware version. You import the firmware version, then you search. So it will show up. It will show up here the firmware here. You just press the program, so it will automatically download the firmware to your controller. So besides the parameter setting and also the programming, you can also monitor all the lift. See here, you can monitor all the lift the signal monitoring. Like the signal monitoring, you can see the status of the door, of the light curtain, and also the input. See here, it is quite easy to monitor, like the input, the output, so lift status. So it easily to observe for what is wrong, which one is the signal is correct. So something like this, and also you don't have to bring the manual board, so it's quite easy. So that's all. That is for the Wi-Fi connection. But here is another case I need to share. So just now the Wi-Fi hotspot, the name and password is factory default. You can also change the name and the password as you like. See here, come here. The module information that you set a hot name and put for example here I change the name to Ian. The password I keep the same. Then just verify. Then you need to reconnect because the name and the name of the hotspot has been changed. So that's all for the Wi-Fi connection. So the next is display. The display setting is easy. But here what I want to share is for the 3 digits. So Monarch, the Monarch controller support setting the floor display for all the possible 3 digits. The two low digits you set from the FE01 to FE40, starting from the physical floor 1 to physical floor 40. That is for 2 low digits. But for the three digits, you keep from F52 and FE52 and FE69. The left 2 digits is for the physical floor setting, and the right 2 digits is for that floor display. And here's a notification. So if you use that features, I mean for the floor display to show the 3 digits, you should enable FA14 bit 1 bit 0 to 1. That is to enable the Modbus communication red band to 3A400. The traditional communication, the red band is just 9600. So this bit should be able to start these features, to start this function. So that is all for to start. So that is all the explanation for easy start. So after that, so now we can talk about the start for the model tuning. So the computer exercise. So what the next to do? The model tuning, shaft learning, or the right performance adjustment, or after the lift running. So that should be a troubleshooting. So kind of that. So now let's start about this. So the model tuning here, model tuning here is depends on the motor is an induction or gearless or gear, and also the encoder like this. But for most of our application, most of our friends, he do the motor tuning outside with a rope connected with a rope hang. So in that case, you just so actually you can refer this from strictly follow our Euro manual. You can find this. First of all, you should set correct the encoder model, the parameters, the motor parameter like the kilowatt current and voltage kind of that, and then F1
F111 to B1. So for here is the example of the gearless PM motor. For the PM motor, the main purpose of the tuning is actually to gain the initial angle of the encoder, because the motor running is depending on the encoder angle, sine cosine encoder, or whatever it is, or it is Inverter. So it depends on the encoder angle. So the motor tuning, the main purpose of the tuning is to get the encoder angle. So during the tuning, so we suggest tuning for 3 times. So after tuning, you just compare the angle you got, F106 you got from the tuning, you compare the 3 times, should be almost same. Then the tuning should be successfully done. So and after tuning, you just inspection the motor. Then you use the keypad to check the controller current output. So and compare that current output to the rated motor rated. So it should be a reasonable value. So if it is reasonable value, then the tuning, you just come across, you just to check across the tuning should be okay. And after that, the next is to do the shaft tuning. Before you do the shaft tuning, so I suggest you inspect the lift from the bottom, not all through the shaft, just from the bottom running up. You check when the lift come across the floor level, the signal should be checked. The leveling signal should be checked. And when the lift travel to the top terminal and down terminal, the slow down switch signal should be active. So after that, so we can start the shaft learning. The shaft learning of 93000 plus. That's maybe 5 years ago, the way we check to do the shaft learning. The way we are doing now is to keep lift in inspection or EEO. You mean the electrical emergency operation, and then keep F111 to 3. After that, switch the lift to normal. It will automatically start the tuning. So and inspection, then switch normal. After that is do tuning. And the other difference is you can start the tuning at any position of the shaft. You don't have to inspect the lift to the bottom, then start the tuning. So you can start the tuning at any position of the shaft. And here is by the another experience shared here is another experience shared here is, so that is for the shaft learning. So there is a difference of F003 and F004. F004 is for the rated elevated speed. Rated elevated speed, when the lift is installed. When the lift is installed, the speed should be fixed. So the rated speed is decided by the motor and by the roping, 1 to 1 or 2 to 1 to 1 or 2 to 1 is by the motor, by the roping. So if the motor is fixed, the rated speed is fixed. But suppose you want to change the running speed, you want to change the lift running speed, you change F003, not F004. So F004, once lift is fixed, the speed is fixed. You don't have to change. Please don't change it anymore. The running speed you can change F003. So after you change F004, you need to do the shaft learning again. So running speed not here. Running speed leaf actual running speed F003. So that is the very important experience I want to share here. And another experience. So in case you have maintained or your leaf is installed 10 years ago and it uses Monarch 93,000, the old version. Now you are going to check the motherboard, or for some reason, or maybe the feature, maybe the motherboard faulty, broken, or whatever it is. You are going to check the motherboard. So here is some logics. So we need pay attention here. First of all, the safety circuit previously is the digital input here. But the new version also support the new version also support here. But we have other option. It is actually also decided by the controller inside wiring connection. So the safety circuit, if the old version you use a new version, change the old version, it can 100% to support the new version, 100% support the old version for the for the safety circuit, for the door lock safety circuit. But the new version, we have the Wi-Fi module here, and also the new version we have CAN bus. We have CAN bus for the duplex and the group wiring connection. And another different here, you probably may experience the problem you probably may come across. That is the HOP, the communication red bond, because previously the 93,000, the old version is support only 9,600, but new version is about both, and in the default setting probably 38,400. So just take a notice here. The new version, to change the old version, you check this parameter, change it to 0. Otherwise the Modbus, the HOP connection may be a problem. Just take a notice here. And another experience to share here, it is for troubleshooting. Now, so Monarch, that is the nice 3000 plus. The troubleshooting is actually relatively easy, because we have very detailed explanation on the error code, and why that error happened and how to solve. We have very detailed explanation. We have error code. Like error 37. So, and also we have error subcode. One error code, there probably are many different subcode. Each subcode refer to a different cause. So it just lead us how to solve that problem. Here I also by the way, not just this, we also have parameter E0 to E9. That is for the error code recording. For detail recording the error code, the subcode, the moment that error happen, what is the input output, what is the leaf status, what is what happened to the leaf. So all the parameters could be saved the moment the error happened. Here I also take a short video here, how to check the error record and what does that mean, and how it can help us. See here, for example, the E0 means the latest error code happened. E1 means the past two. So the new one. So every new arrow will be stored, will be restored in E0. That is the latest arrow always be E0. See E0, the left two digits means the moment that arrow happen where the leaf stop. See here means 40 or 51 or 51 arrow happen at floor physical floor 1. Physical floor 1. And E001 means the subcode. Means when the arrow 51 happen, the subcode is 101. And another one to be shared here is the adjustment of the writing comfort of the writing comfort. And here we use for the starting. First of all, the starting to overcome the rollback or jack or starting jack. We use F201 to 2 for the automatic compensation at start. But a reminder here, when we do the motor tuning, we should keep F801 to 0. To do the motor tuning, we keep the 0. After that, well, when we start to adjust the writing comfort, we keep it to 2. This is for the sine cosine for the PM motor. But also, by induction motor, it also work. And after we keep FA01 to 2 is automatic compensation and start without a load cell. Then after that, we use F211, F212, F213 to change the writing comfort. The changing way here is to modify F211 first. Try to reduce F211 as much as possible till there's no rollback. Then keep F211. And the way of in case there's a noise or something, we can check F2. I mean, at the starting, we can check F212, F213. These two parameter. So either increase both or decrease both. And also here at the starting and the stopping for the brake relay. The brake action relay at the starting and at the stopping. So we can use that parameter to overcome the brake relay. And also for the inverter output input, the torque, we can adjust the time to solve the motor noise issue. So that is all the explanation for the NICE 3000 Plus. So now we are going to share some of the features of the NICE 1000 Plus. So NICE 1000 Plus, NICE 3000 Plus, then share the basic idea. Then share the basic idea. And the main difference is the HOP, COP, the CANTOP, the NICE 1000 parallel connection, and standard product support F-floor. F-floor means four character F-floor. It has the same 24 digital inputs, and output. The difference here is we have relay output for binary indicator for 7-segment indicator directly connect to the 7-segment indicator here through the relay. And also we have a bidirectional command input for call input and bottom illuminator. And the last one is NICE 100 plus. So NICE 100 plus. So we don't, to be honest, we don't have much project to use that product. The function is just very basic, very fundamental. It's that if you have some project, the requirement is it has a minimum requirement is going up, going down, and can stop, and you cannot install a encoder as a model, then you can try. But we have very limited available models for this model. We just have 5.5 kilowatt and 7.5 kilowatt at 400, and model fast 200 only 1.5 kilowatt and 2.2 kilowatt. It's for up to 1 meter per second, and for induction model. And we usually install lighting sensor, and it is quite same. But the difference is the acceleration and the deceleration switch at each floor, for up and down. At each floor, you should install that slowdown switch. So basically, that is all for today's sharing. So no, we still have time. Then we can talk some of the any question you can share with us. Then we can talk about it.